Hello, my name is Anand Mahadevan, and for my project I decided to make a KNN regression model to predict ratings of an episode of The Office based on various features. So intro to The Office, it's a popular American TV sitcom that aired for 9 seasons from 2005 to 2013. It's a mockumentary set at a paper company in Scranton, Pennsylvania, and has a similar documentary style to that of the Ricky Gervais-led British original, also called The Office. There's Jim, the likable employee whose best defined feature is looking at the camera funny. There's also Dwight, the successful coworker who speaks his truth and is Michael Scott's best friend. And speaking of Michael, he was the show's star from seasons 1 to 7 and can be easily classified as the clueless boss that consistently makes a fool of himself, being the one who held the office together with his ridiculous antics and general clowning. So let's get into the data. We have the season number for each episode, its title, its ratings out of 10, the number of people who voted for the ratings, its viewership in millions, duration in time, with minutes as the unit, and the number of guest stars for each episode. So for our model, we're going to use votes per rating, viewership in millions, duration in minutes, and number of guest stars as our features. And for our target, like I said before, we're going to use ratings out of 10. We're not going to use episode title for our model. For one, it's text and it's not very useful information regardless to predict ratings. And for season number, it isn't useful for us to say an increase in season, either increase or decreases in rating. It's not accurate enough. So to see that, we can see our rating versus season number scatter plot. If you can focus on seasons 1 to 5, it appears as though the ratings are fairly compact together with no clear outliers. Seasons 6, 7, and 9, however, appear to have much larger distributions in ratings, with season 6 featuring episodes of ratings from 6.8 to 9.4. And finally, season 8 features all of its episodes doing quite poorly in terms of ratings, at least compared to the other seasons, featuring the lowest rated show episode in its history being Get the Girl at a rating of 6.6 out of 10. So let's continue to features that we will be using in our model, rating versus votes for rating. There would appear to be a logarithmic relationship between ratings and votes for ratings. Focusing on the 3 clear outliers with a large amount of votes and high ratings, one of them had appeared right after the Super Bowl and had been widely considered one of the funniest episodes, Stress Relief, and was about Dwight personally setting fire to an office trash can, causing absolute pandemonium and Stanley to get a heart attack. The other 2 of these episodes feature Michael in some major way. Goodbye Michael was the last episode of season 7, where Michael made his exit to the show due to NBC not renewing his contract. And finale, the last episode of the show, featured Michael appearing as a surprise guest character at the very end as the best man for Dwight's wedding to Angela. So next up we have rating versus viewership in millions. It appears that all but one of these episodes, being the outlier, have a direct correlation between ratings and viewership. This one outlier is the episode Stress Relief that appeared right after the Super Bowl, very likely increasing viewership by a large margin. So this is a scatterplot of rating versus duration in minutes. If I drew an imaginary line at 40 minutes, it would appear that the ratings of these episodes tend to be greater than the episodes that are less than 40 minutes. This may be due to the longer episodes being produced at a higher quality script, the audience being more engaged, and various factors relating to that. Next up we have, and lastly, our final visual is rating versus number of guest stars. It seems that for the few episodes with 3 or more guest stars, or even a guest star in the episode, they tend to have larger ratings on average. However, these episodes having a high rating may be due to extraneous factors like the quality and content of the episode and not directly due to the number of guest stars present, but there is a clear relationship between the number of guest stars and ratings being positive. So let's get on to our model and deciding on what K is optimal. So for our imports, we're going to need to scale our data, of course, for KNN. So we import standard scalar. We're going to use make pipeline to combine standard scalar and K neighbors regressor right here. Of course, this is what we want to do. We want to make a regression model. We're going to use cross-val predict to get predictions from our model. And we're going to use mean squared error and R2 score, our squared coefficient, to test our model. So for our X or our features, we're going to be using 3 beyond, which is just votes viewership onwards, the 4 features I mentioned before. And for Y, we're going to be using the ratings column for our target. To determine the optimal K, we're going to find which value of K results in the lowest mean squared error. So I will have a for loop for K in range of 1 to 30, which really means K's of value K equals 1 all the way to K equals 29, because that's how the range function works. We're going to make a pipeline, like I said before, with standard scalar and K neighbors regressor, and neighbor is going to be equal to K for now. The weight is going to be distance, meaning closer points are going to be valued higher. Y predict is cross-val predicts. The pipeline with our targets are, our features, our target, and CV equals 5, our folds. It's a very normal number, default number. We're going to use error.append. We're going to append our mean squared error between our target and our predict from our model to this list, and then we're going to plot from 1 to 29, like I said before, with the range function and error. And it looks like from our plot that K equals either 7 or 8 would be our lowest our K that would result in the lowest error. But just to make sure, we'll print it out. K should be error.index min error. So this is the index from our list that goes from index 0 to 28. That will result in the lowest error. So if we have 0 to 28 and this is the range is 1 to 29, you have to remember to add 1. I actually saw a website where I was doing research on how to do this process, and this person actually forgot to add 1. And this person had a career and everything, so it just goes to show that you have to watch out for the small things, no matter how accomplished you are. So in the end, K should be 8 as our optimal value. So we're going to use the same process from our error for loop, but put K equals 8, of course, and we're going to print out the Y predict. This is an array representing the ratings produced by my model based on that episode's viewership in millions, votes for the rating, duration of the episode, and the number of guest stars for the episode. And see the mean squared error of this model with K equals 8. It is 0.174 with a R squared value of 0.496. So as a conclusion, my model has an R squared value of 0.496, meaning that 49.6% of the variance present in ratings can be explained to the variance of votes for ratings, viewership, duration, and number of guest stars. In order to improve my model, I would employ methods to better assess which features more strongly correlate to ratings and find more features to add to the model, as that will decrease bias, like the number of times a character had a line in an episode and other features like that. Overall, I have produced a model that will predict the ratings of an episode of The Office based on numerous features such as viewership, votes for rating, duration, and number of guest stars on the episode. And for my 3 questions, what was the mean squared error of my model? Why is the +1 necessary for the statement print K should be error.index min error +1 to print out the correct optimal K? And finally, from my clean data set, what 2 variables weren't used in KNN regression? And and B, why were each of them not used in the KNN regression model. So thank you for watching. Goodbye.